Welcome to our project presentation for Catalog, a web-based application designed to support small animal shelters with managing cat adoptions.
In this presentation video, we will walk through our project, the data module, front end, back end, and the database management system.
In each section, we will walk through our goals, tools, and decisions into how Catalog was built and how it works.
Our project is called Catalog, and our goal is to streamline cat adoption processes. We wanted to create a simple and easy to use web interface where staff can manage cats and adoption applications, and also for future adopters to view available cats.
The key features we included are the ability to browse adoptable cats, an employee dashboard to manage records, and a backend API that connects directly to our MySQL database.
To build the web interface, we primarily used HTML along with CSS, JavaScript, and Bootstrap. The backend comprised of Python, Flask, and REST API. The data was stored in a MySQL database. We also used GitHub and Discord to manage collaboration and organization throughout the project.
To provide a better understanding of how our system is organized, here is the entity relationship diagram for our database. Catalog is built around the following main entities: adopter, cat, adoption application, and employee. The diagram shows how these entities are connected. For example, each adopter can submit one or more adoption applications, each application is linked to a specific cat, and applications are reviewed by employees. This structure forms the foundation of our backend and ensures the data remain consistent, organized, and ready to support the features we wanted to include.
For the data module, we created a combination of real-world and synthetic datasets. This allowed us to simulate a working cat adoption platform with realistic information, while also demonstrating the system's core features in a customizable way. The structure we used also makes the system adaptable for use by actual animal shelters, should they choose to implement a similar tool. We created datasets for four key entities: cats, adopters, adoption applications, and employees, which plays a role in powering the back end and supporting functionality throughout the system. For our cat data, we pulled real records from the Austin Animal Center Outcomes dataset, which includes over 100,000 entries. As you can see in the screenshot, the dataset covers a wide range of animals, not just cats, but also dogs, birds, turtles, and more. It includes details like animal ID, date of birth, outcome type, breed, color, and age. Since we were building a cat-focused system, we had to clean and filter this dataset to include only cat records. After pulling the original dataset, we cleaned and formatted it using Python and Pandas. First, we removed all non-cat records since we're only focused on cat adoptions in our project. Then we standardized values like gender, spay or neuter status, and vaccination status to keep things consistent. We also converted the raw age data, which was listed in weeks or months, into a numeric format in years. Lastly, we added a few new fields like health status, adoption status, and a photo path to match the structure of our system. For the other parts of our system, like employees, adopters, and applications, we used the Faker library in Python to generate realistic data. This included names, emails, and even randomized dates for application submissions and reviews. We also made sure the data matched our ER diagram, like ensuring every adoption application is linked to a real cat, adopter, and employee. This helped us simulate a functional and realistic adoption system while keeping the data fully synthetic.
Since Catalog is a web-based application, our group decided to use HTML, CSS, and JavaScript to create the front end. We also utilized a framework called Bootstrap to help us design the user interface. Catalog's front end consists of two different views, one for potential adopters and one for employees. Adopters can view three main pages: the home page, the View Cats page, and the adoption application page. The home page serves as the landing page for all visitors of Catalog. The View Cats page allows potential adopters to browse the available cats ready to be adopted. The adoption application page allows for the submission of applications and has pre-populated fields for the cats selected from the View Cats page.
The screenshot on the left shows the Views Cat page. When the page loads, it makes a fetch call to the REST API endpoint of cats. This returns a JSON array of cat objects. The script filters to only show cats with a not adopted or returned status. For each cat, a bootstrap is generated using the crate element and inner HTML. The image is selected between two photos and alternated using the modular operator. Each card also includes an Adopt Me button that links to the adoption form page.
The adoption application page is where potential adopters can submit their applications to adopt a specific cat. On this page, adopters can enter information about themselves, including their name and contact information. If the user clicked on the Adopt Me button from the View Cats page, the cat information section of the adoption form will already be filled in. Employees are allowed to view pages that are hidden from other visitors to Catalog. After logging into the web application with a valid username and password, employees can view a dashboard of statistics based on the cats in the shelter, the Manage Cats page, and the Review Adoption Applications page. When an employee successfully logs into the system, they are greeted with an employee dashboard. This dashboard provides statistics for the employee to view, such as the number of cats available for adoption, the number of applications to review, and the number of cats that need to be vaccinated, spayed, or neutered. This information is fetched from Flask API. Cats and applications are filtered based on a certain field, and then the filtered results are counted and displayed. The totals are updated as changes are made to the backend database.
This is the Manage Cats page designed for employees to view and manage cats in the system. On page load, a fetch request is made to the Cats API to retrieve all cat records from the backend. The data is rendered into a Bootstrap table by dynamically generating rows. We also added multiple UI components, including 4 select dropdowns for filters and a text input for a live name search. The function uses filter methods to update the displayed table rows based on selected filter and search criteria.
A screenshot of the Review Adoptions Applications page is shown on the left. When the data is received, a renders apps functions iterates through each application and generates a table row that includes key application details. Statuses are represented using color-coded Bootstrap badges, such as yellow for pending and gray for completed decisions. Each row includes a View Details button and Approve and Reject buttons. The page on the right is the View Applications Details page. It uses URL search params interface to extract the application ID from the query string and fetches the data via a RESTful GET request. Once the application object is retrieved, a secondary request is sent to the adopter's ID API endpoint to fetch the adopter's personal details like their name, email, and phone number. This ensures employees can view full application context in a clean layout. The backend of Catalog consists of Flask, a lightweight Python web framework. It is a simple way to build web apps like ours. We also used the Flask Chorus extension so that the front end could successfully fetch data from our backend without cross-origin issues. To connect our backend to the MySQL database, we use the MySQL-connector-Python library to let us execute queries and return the results as JSON. Our app.py file has different API routes for each database, like API cats, API adopters, and API applications. This makes it possible for the front end to request and display data. The screenshot here on the right shows the start of our app.py file.
To run the backend of Catalog, we start the Flask server by running python app.py, which launches the server locally at the HTTP link provided. When the server is running, it listens for incoming requests. The API routes are accessed by the front end using fetch function in JavaScript. In the screenshot, a GET request was made to the CATS API and the server responded successfully with a status code 200. This shows that the front end and back end are connected and working together to retrieve the data.
Catalog also includes a login system to prevent certain pages from being accessed by unauthorized visitors. The employee login page compares the information entered by the user with the usernames and passwords stored in the database. If the login credentials are incorrect, the user will be redirected back to the login screen with an appropriate message. Once a correct username and password are entered, employees will be redirected to the dashboard, where they can then access additional pages. These pages can only be accessed with an active login session, so if the user clicks the Logout button and then tries to access the URL for a certain page, they will be redirected to the login page. This system was created by using routes for each of the pages in the app.py file, where certain pages are only rendered if there is a current login session. We chose to use MySQL as Catalog's database management system. We began the process of creating our database by first making an entity relationship diagram. This allowed us to better visualize how the entities in our future database would interact with one another. We then used the MySQL command line client to create catalogs tables based on our ER diagram. Next, we used MySQL Workbench to load the CSV files with the preprocessed data into the correct tables. Finally, we dumped the database as a SQL file to allow each team member to access the database. There are 5 tables in total in Catalog's database: adopters, adoption app, cats, employees, and reviewed by. Each table contains a variety of attributes, with each field given appropriate data types and constraints. We created primary and foreign keys for each table to allow Catalog to display specific records from a given table or several tables at the same time.
Thank you for watching our presentation for Catalog. To learn more about Catalog, please click on the links to our video pitch and the final presentation.